Hello, and welcome to my math problem explained in 5 minutes. My math problem starts out with RSA cryptography. Cryptography, as you know, is the scrambling of messages. Like you write a letter, you reverse that letter with different symbols so it can be read by just anybody. And RSA is the first public available public key cryptography to the public. It started back in 1977, and it was based on the simple idea of only the keys could be exchanged, would not have to be exchanged in order to secure the thing. That's complicated. I don't really have time to explain it, but read on Wikipedia and look it up. It starts off with the math of it is as simple as n equals p times q. Now n is the semi-prime there. It's the main thing we're given. It'll be given in the math problem, so we don't know p times q. P and q are both two different prime numbers which are multiplied together to get n. But knowing p, when you only know p or you only know q, those are the ones that are hidden. N is what you know, and p and q, you have to find out p. You have to find out n, not knowing p and q, and it's called a one-way function. It works one way, but not the other. It's really hard. You plug it in, it scrambles it, but it can't. It's the reverse of this math is very difficult, and that leads you to me here, Construct This Corner. I've been trying to figure out this math problem since about 2007 now. I originally stated that the math problem could be solved by using a logarithmic spiral, and that's where my idea originates. But really, what I did was take patterns of the multiplication of numbers, just simple multiplication. I took patterns from that and derived these equations. Now, this equation here, I plugged in the Wolfram Alpha. It's a really easy way to learn a lot about your equation really fast. And it tells you the derivatives, the intercepts, everything. But the thing was, before my equations, there was no function that was graphable to show the relationship of n and define p and q. Now I refer to p and q as, I refer to p as x, the smaller one, the smaller prime number, and q as y, the larger prime number. But this equation I have here, f equals parentheses, 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 so on, x squared times 85. The 85 is the PNP in this problem. I plugged it in. I typed in 85 because it was easy to graph on Wolfram Alpha, but it'll work for all n's. If you plug n in 80 where 85 is, it should work. And it seems really complicated, but it's simple. But for what I did for my lessons plan is this right here, and I wanted to write pseudocode for it. Well, what pseudocode is, all pseudocode is like code. It's like generic code. It's not geared to any compiler like C++ or C# or Java or any language or computer language, but it's code that is logic, like if-then statements, if-then do this, if-else, loops, and equations, and you get the idea. But I was gonna have people plug in the equation, which again is this really big equation. But the thing is, it's graphable, and I don't believe there was a way to graph the prime factorization problem, n equals p times q. I don't believe there was a way to graphed that before. I could be wrong, but I have three equations that two that I know will graph it, but this is one. This is one equation here, but when it's graphed, it means you can learn something about it. It's a function. It's no longer n divided by x is n divided by p is equal to q, or n divided by q is equal to p. Like that's trial and error. Well, this one is trial and error too, because I cannot solve this polynomial equation, but it's trial and error. But it tells you, it gauges where you're at. It'll be like PNP is 85. I choose a value of 3. It's greater than 3, so I choose 7. 7's too large, and then I choose 5, and I get it. But you could do that on paper in your head. But when you get into really long digit numbers, which I don't know how to program yet, because programming 100 digit numbers is complex. But I use Mathematica to help me solve it. But with large numbers, this should help, and that is what this is on Wolfram Alpha. It's like it's the minimums, and you see a maximum of x equals 4.7. That's around 5, but it's still confusing. That's why I want people to work on this thing. But the fact is, it's graphable, and this is where we start. And here's here is just n minus the n minus my equation n. It's 85 minus, which equals n, minus my equation, which approximates n. So it's n minus n. And we're looking for whether that equals 0. So we'd have to go through this, and this is really, this actually is more complicated than my problem is. Some of this stuff here, some of it's unusable, but I believe if we take the derivative, where it approaches 1, it should fall at n, where n is n, where I know it's confusing. I have trouble explaining it, but I'm working on it. So that's basically where we're at, where it stands now. But if you look at this, it's complicated, yeah. But I'm gonna try to redo my lesson plan. Redo this introduction, and we'll see where it goes from there. Thank you.